right, let's give everyone a few moments to come on in. All right. Hopefully everything's going copacetically. All right. All right. Let me make a little bit of adjustment. All right, well, let's get this show on the road. Greetings, tech artists around the world. It's 12:30, it's Friday, and that means it's time for Tech Art Talk Live. My name is Chris, and I will be your host today. So, a couple weeks ago, we started working on a Python tutorial to introduce everyone into Python. Now, we're almost about halfway through the series, and I hope you're sticking with me because this is a really impactful full series. We've got a lot of students who are going, "Oh, I'd like to learn no Python programming. I'm not a programmer." But I tell you, if you stick with it, stick with these 7 lessons. Well, actually, it's just 6 lessons, and the introduction is first. If you just stick with it, you're going to do all right. You go through and you practice some of this stuff, and you're going to do just wonderfully. I promise you. Stick with it. You'll see the rewards. I promise you. Okay, last week we got into a little bit of the Python data sets, and we dealt with the Python kind of functions. And we're going to expand that much further, and we're going to take a big dip because one of the big things about Python that makes it so freaking wonderful is that it's an easy access to object-oriented programming. What's object-oriented programming? You might say, and I say it's oops, OOPS. You know, get it? Oops. Yeah, that's what it is. And we're going to go in and give a sampling of what you could do with ops programming today. So let's get this show on the road here. All right. All right, we're good. Okay, now this is a crash course into OOPS. We're going to teach you the basics and the fundamental stuff of ops as much as we can in as little time possible. All right, so I'm going to lecture here for a little bit. Okay, OOPS, as we said, stands for Object-Oriented Programming. And this is basically all of the attributes, which is all the data, and all the functions associated with one class is put all together into one critter, into one object, into the scene, one entity, if you would. And so whenever you want to create an instance of a data class, meaning like you actually want to use one of these objects, you have to create an instance of it. And that's basically bringing it to life. And all you know that if you're going to use this data class, you don't know what's in the data class, you don't know how it's behaving, and honestly, you don't care. You just know that it does lots of cool things and it does it well. And because the data class, it hides all the data that it doesn't need whenever you're interfacing with it, whenever you're programming with it. And that's what's beautiful about it, because once you created a object-oriented class, then you don't need to worry about it. You can forget about all of these algorithms. You can forget about all these behaviors. It all is taken care of you, and thank you very much for your classes. Okay, if you've ever worked with blueprints, blueprints are the quintessential essence of what classes are. Okay, they have everything that a Python class has, but they have the little graphical nodes that you work with instead. So they have constructors, they have overrides, and they have methods. And what all that means is we're going to go into that today, but we're going to go and show you what all that is, and you can call the class and interact with them directly, or you can work with them indirectly. And so if you've been using Python blueprints already, guess what? You've already been programming object-oriented programming. So congratulations. All right, let's see. All right. Now this is how in Python that it ultimately looks. You have to start with the word class in the very first line, class, and then your class name followed by a colon. And then when you put in triple quotes, any kind of documentation you put in triple quotes, this is going to become part of the class and it auto documents. And so whenever you ask Python for the documentation or the information on how to use this class, anything that's going to show up inside of these triple quotes is going to show up, and you're going to use it in order to show your user how to use the class. All right, the first content here is you're going to create a function or or a method inside of your class. And the first one that I usually like to create is called my init, or this is otherwise known as a constructor. This is the code that gets called every time you instance your class. Automatically, it gets called, and whatever's in the code block, it gets executed. Note that inside of its parameter lists, inside of its arguments, is the word self. And the self is kind of like a pointer to itself, meaning it's saying like, okay, what do we want to perform this all? We want to perform it on me. That's what we want to perform it on. And then inside of your class, you have all these other methods inside of that, and each of those are called a code block. And each of these methods, the first parameter has to be self. That's what Python looks for. It looks for self, and you can't have it. But then you can put other arguments, like in this case, I'm putting argument 1, argument 2, and you can use any kind of argument that you want. And really, this is all that a class is. Now, there's a whole lot more details that we could really dive into and really fiddle around with the minutia, but I want you to understand the essence of what object-oriented programming is all about, and this is what's going to kind of get you going. Now, what do you do when you want to instance one of these buggers? All you have to do is create your variable name, and then you assign it, and that's what the equal sign means. You assign it to the constructor of the class. So basically, I'm just calling the class, and what this does is it calls the constructor for me automatically. I don't have to worry about it. All I have to do is says, hey, give me an instance of my class, and it'll give it to me. And it'll say, okay, and it will do all of the gobbledygook and do all these code for you that you don't have to worry about. This is really, really cool, and I'm really loving it. Okay, this is the thing you got to look out for. Whenever you're using variables that are inside of the class, meaning that the variables are stuck inside the class and the class works with the variables, and you want the class to remember these variables and to maintain them, you have to use the self namespace for these variables. Okay, the self namespace means is that you're working with a variable within the context of the class, and then you're not working with a local variable that's local to that particular method. And it keeps it differentiated, and it gives you kind of like a centralized local memory system, which is really, really awesome for storing large amounts of data. Really, really awesome stuff. All right, cool. Now what I'm going to do is I'm going to shift my screen here and get me some Houdini, and we are going to go ahead and create a class here. All right, we're going to start off simple, as with always, and we're just going to basically create a Roberto class. All right, I'm going to create a brand new tool. I'm going to create a new tool here, and we're not going to be using too much of that window here, but inside my options, I'm going to call this Roberto, and my label is going to be Roberto. Okay, now let's go ahead and script this. All right, I'm going to go ahead and put all this down here, and let me explain with this. Okay, we're going to first start off with the call to the class. I say class Roberto. I'm going to call this class Roberto, and then I'm going to put some quotes inside of it, and I'm going to say like triple quotes. This is my Roberto class. All right. Oh, I got to spell right. This is my Roberto class, and this is a capital L. Don't want that, and we need one more quote there. So there we go. And now here's my constructor init, and all we were doing is self. And so all we're going to do here is what we went through last week. We created the 3 function calls we need in order to create anything. We first identified what the top or the top of the Houdini node strain is, and I call it self.top. Then we create a new variable called self.container, and we're going self.top create node geo. Notice that I'm locating these local variables as self.top, self.container. I'm using the self namespace because that means I want it to save on the middle and the inside of there. But what this is going to do, this create node geo, this is going to create a geometry node, and I'm going to say, okay, self.container, then create some test geometry of rubber toy and assign that to self.roberto. Okay, nice and simple. It should be really going here. Now, in order to start this going, I say my Roberto equals Roberto. Okay, very simple. I'm going to hit apply here, and then I'm going to hit my Roberto button, and then we have a Roberto. Okay, not too shabby. It's just a little button. Basically, we're duplicating right to where we were last week when we and the week before when we just used the basic couple commands. We created a function in order to create Roberto. Okay, so now we really haven't done anything too spectacular except put all this under the class variable. So let's start playing around with it. Now suppose that you wanted to create multiple Robertos and you each wanted them to have their own unique name. You know, they might not want to go around talking about each other. So let's put in a variable or a parameter to my constructor here. So I'm going to say, comma, name equals, and I'm going to say, oh, it's Roberto. All right, then I said name equals Roberto, and then, okay, let's go ahead and do something with that. So before we go ahead and create, I'm going to go ahead and, I'm going to put some documentation in here. I forgot to put in the documentation. Let's say, this is my Roberto constructor. Okay, now I've got that. So let's go ahead and create a local variable to store the name. So self.name equals name. Okay, our class does know what our name is. And so if we wanted to put this into the Roberto, we would say, okay, self.container. What we could do is we could call the container whatever our name is. And so I'm going to say put a comma here and I'll put self.name. And then I'm going to put the same thing here for my actual model, self.name. Okay, and now how do we call this? We're going to do it the exact same way, but then I'm going to call it Roberto. I'm going to call it something like, oh, I don't know, Phil. All right, we've got that going. Okay, now let's give it a try here. I'm going to press Roberto, and we see that it is, okay, did we do the name? Self.name equals name, name equals Roberto. Okay, and it still is not doing it correctly. Let me see what I did wrong with this. Let's try this. Okay, and everything basically looks the same. I do not know it. Let's try this again. All right, now click Roberto, and it is still not functioning properly. Okay. All right. Okay, the joys of live demonstration. Okay, so let's test to see if this is actually working. This is bugging me now. So do we have anything going here? We had, okay, class Roberto. So we print self.name. Okay, we have to do this after that statement. Ah, look at here. I have a typo error in here. If I self.name, we have, okay, I know what's wrong here. This is the reason why it's not working properly. All right. Okay, I knew, okay, we have a problem here because, all right, my parentheses were not correct. My little quotes were not behaving. So let's apply here. Click Roberto, and it's still called the same. And is it even calling that? Okay. My Houdini has been acting up with me, folks, lately. So I am going to call this, I'm going to copy this and cancel. And then I am going to create a new tool. Call this Roberto 2. and I'll call this Roberto 2. And then for my script, I'm going to paste this in here. Okay, I'm going to click apply. And then click onto Roberto 2. Oops, we've got a bunch of Robertos. Let's try this one more time. And there it is, Phil. Weird stuff, huh? I don't know why, but if we go inside of Phil, and there it is. Beats me. I have no idea why, folks. We're going to have to talk to the SESI folks about that. Oh, I'm sorry, side effects. They don't like to be called SESI anymore. But anyway, let's go ahead and break this up a little bit. Now, suppose I wanted to do special stuff just for the constructor and just for the Roberto. And so I want to create a separate method for my container and a separate version for Roberto. So I'm going to go ahead and grab this information here. And so I'm going to create a brand new method. So it's called make container. And so I'm going to call this by saying, okay, self.make container. And what this is going to do is going to call this particular function. Notice that we don't have to call self in here because that's understood. Now this gets a little bit confusing, so hang in there and stick with it. And just know that you pretty much call the self pointer to itself when you're creating the new method, but you don't have to call it again in order to call another method that's inside of it. Okay, so let's go and see if this all works. So we'll see if this actually creates. I don't want to get too far. Click apply, Roberto 2. Okay, and something funky happened here. All right, we have a missing Roberto here. All right. All right. We are just having lots of Houdini errors here today, folks. And I have a hunch I know what's going on. So what I'm going to do is I'm going to copy all of this information right here. And then I'm going to restart my Houdini. Cancel. Okay. Okay, cancel. We are having serious memory issues here. Now, this is not going good here. This is quite embarrassing, folks. Let's see if we can get something going here. Bring up my Houdini again. But I guess that's the reason why you're tuning in to this live broadcasting, because you wait to see like, oh, let's see how Chris screws up. The other guys, they never screw up. Well, that's because they're all recording and they get to edit all their stuff at any time. All right, so I'm going to go into my, here we go. And I'm going to go ahead and add myself a new shelf. And then I'm going to add a new Roberto tool. Roberto, okay, all right. We're going to go ahead and hit the script here. All right. I'm going to copy that, paste that in here, and I'm going to make sure that we don't have any of those typos that were so difficult to find. Here we go, Roberto. Okay, we've got that going. We're going to say make container. Okay, that's good. Here's our thing. All we're doing is duplicating, and we moved that command over. We're making the container and put it down into a separate function. Now here's something different. What I did here was I called make Roberto. And then we moved the create node over where we actually create the Roberto here. But I also created two more nodes. I said self.out equals an output node. And then I called it, the name for my node would be out and whatever the name of my class is. I have no idea what the class is going to be, but I call that. and then I set my input to 0. So basically, I hooked my Roberto node into my output node. And then I did something. I said, okay, self.container, lay out the children. That means make everything look sexy, make everything look nice. So if I hit apply here, and if all goes well, there we go. There's Phil. And if we go inside there, there's Phil going to an output node. Oh, look at that. I forgot to hit the display button on here. Okay, so if we could change that, no problem. We're just going to go to the Roberto flag, and then I want to put my display on my self.out node. So I go self.out dot set display, and then we're going to set that to true. Okay, and so what that's going to do is that's going to actually get all my stuff, and it's going to make the output node the actual display node. So if I click apply, and if I come out of here and go to Phil, okay, are you with us, Phil? And there it is, set display. This is not working. Oh, you gotta love it. You gotta love it. Why aren't you behaving? Let's see if we were to do this. Here, check this out. Okay, foo equals this node here. Okay, why aren't you behaving? So we want to turn you on. So we say foo dot set display. Oh, it's display flag. I. Oh yeah, by the way, Tukmung Namui, all you out there. Today is Tet. So Happy New Year, everyone. Year of the Ox. Ha ha ha. All right, so let's see if this works true. And then click that going. And we hit that. Does that change the flag? Yes, it does. Good golly. So it's not to set display flag. Okay, jeez. Apply, up, okay. We click this, see, okay, let's try to run it again. All right, click in here. It just refuses to do this. Okay. This was just for cleanup, and I'm gonna come back to this later. I have a hunch that's going to break up. So what if we wanted to go and make things a little bit more sophisticated? Like we wanted to put in some initial rotation and translation into Roberto. Well, what we could do is put those parameters inside of its callback or inside of its argument list. So in here, where it says init here, where it says name Roberto, I'm going to add some more parameters. I'm going to say translate equals, and I'm going to create a default tuple of my position. So I'm going to go 0, 0, 0, comma, and here this, folks, in order for brevity, in order to make things look a little nicer, I'm going to indent this and push this on to the next line. So what we're doing is still keep on going. So I'm going to go rotation equals 0, 0, 0, and then I'm going to take scale equals 0. Oh, I want this to be 1, 1, 1. And I'm going to put one more parentheses here to finish things off. Okay, so now what we're doing is we're going to go say, okay, let's go ahead and initialize all the rotations. And so let's go ahead, and once we identify the name in here, let's go ahead and set these to a value. So we're going to create a function for that in order to handle all this. So I'm going to go self.set transformations. And then we're going to send it the translate, the rotate, rotation, and the scale. All right, now this method doesn't exist yet. So what I'm going to do is I'm going to copy this just to make sure I'm not typo anything. And then I'm going to create a new function down here called def. And then let's call it right here, set transformations. So I'm going to get rid of that self here, and then I'm going to put the self right here. Okay, and then I'm put a colon here. And so let's just set this thing right here. So let's go self dot translate equals translate. Self dot rotation equals rotation. And self dot scale equals scale. All right, and now we're just going to leave that here because all we're doing is set the local variables. So what we can do now is we can make an update to our container node because this really affects our container node. So if we go ahead and tell the container node to do with all this, then we let the container node do with all the container stuff, whatever that container stuff is. So we'll just say self.container dot parm tuple, and we're going to create this T equals, and we want it to be self.translate. All right, and hopefully this is good. So I'm going to go ahead and copy this and paste it. So we got T, and then R for rotation, and S for scale. And we're going to set this to rotation, and then scale. Now, if all goes well, we should be able to move Roberto around with some initial values. So if we click apply, click fill, delete, all right, click this on here, and everything worked, and inside everything is fine. Okay, everything is working. All right, now let's actually put some values to it. And so delete this, and so let's call fill, and let's give them some rotation. So let's say translate equals, oh, I don't know, maybe 2, 2, 2, and then rotation equals, oh, let's go, 45, 45, and then 45, and then put scale equals, oh, I don't know, 0.4, 0.6, and maybe 0.8. Okay, so then we put all these initial values in here, and we have no idea, once again, what we're doing. We're just saying, okay, give us all this stuff. Click apply, and then we click Roberto, and there's Roberto, and Roberto is all over the place. And so we go with P, and he is not moving at all. So what we forgot to do is we forgot to actually make the rotation. So okay, so if we got self.translate, self.rotation, and self.scale. Okay, so obviously we have forgotten something here. So set transformations, set translate, set rotation, set scale. Okay, so these values should correspond to each other. Okay, and there we go. We should, so this Roberto should update for us automatically. Okay, now let's see if this is actually all working correctly. So I'm going to go just see if I can print out these values. So print, let me see if I'm actually working here. So if we're getting here, I want to test this. So print self.translate. Is this working? So I just want to test to see if this is working. Click and get rid of fill here. Click Roberto. All right. And so it didn't even display that. So we got nothing here. So looks like we have another memory error here, gang. We're not getting anything. Do we even get this? So Hello? Are you even working? Because we know it's got to work here. So delete, because this is going to work. No, it didn't even print out. Okay, I'll give side effects a little break here. The implementation, I'm working with Python 3.7, which is brand new. And this is prone to give us some errors. It's going to give us some errors every now and then. And it's all acceptable, I suppose. Just not during live broadcast. Okay, I'm going to copy this and hit cancel. And I'm going to see if we can create a brand new one. And create us a new tool here. I call Roberto2. And Roberto2. Click apply. All right, and click the script, and here's our script that we got in here. And so here's our Roberto class. It's forming out nicely. And I'll click Roberto2, and we get nothing. Okay. Things are not groovy. All right, we click apply here, and things are not happening. Okay, so Houdini is just not happy today. It is not displaying anything. All right, I'm going to copy this, and then I'm going to get out of Houdini one more time. Cancel. Okay, let's bring that up again. Discard and quit. All right, I'm going to call Houdini one more time. So please work for us today. All right, let's try one more time. We got a new tool. Click script. And there's my Roberto script that we were working on before. And so click apply. All right, click save. All right, let's go. Aha, now we're getting some stuff. Syntax errors is much better than nothing. Where is our syntax error? Okay, error can't assign to function call. Line 17. Okay, thank you. So here on line 17, okay, self-container.parm tuple. Okay, now this absolutely makes no sense whatsoever because this shouldn't be functioning like that. And this is really not very fun. We click apply here. And it says can't assign to function call, line file tool 6, line 17. So this is something that's not even behaving properly. So this error has nothing to do with what we got. So, okay, we're going to continue this on, and we're going to abandon poor Roberto. And we're just going to keep on plugging along here. We're going to go on with another thing because we've seen how we can go and distribute and make more functions. And ideally, this was supposed to work, but it's not. Don't know why. But what we can do is move on to something called, okay, let's expand the class. We can do some operation overrides here. So I'm going to go ahead and create a new class, and then I'm going to go on to even more information. And so I'm going to create a new class, so a new tool, and I'm going to call it swatches. All right, swatches. All right, we've got the swatches. Okay, click here. I'm going to put that in here. All right, so what we have here is almost the exact same situation, but we're not dealing with Roberto anymore. Sorry, we're going to be dealing with just a shader ball. We've got the swatches. We're going to create the constructor, which is our initialization function. And so instead of the position, rotation, and translation, we're just going to send it a color. So the color here, we're going to send it in as a 3 tuple, and we're going to send it 111, which is the color of white. And so we're going to set our local name. So self.color equals color. And then we're going to call it the self swatch, whatever count this is. Oh, okay, swatches dot swatch count. Oh, there's one thing I forgot to include on here was that in here you can create something called a class variable. And I'm going to call this swatch count equals 0. Okay, so notice here that this variable now is a variable that belongs to the class, but it doesn't belong to any one of the methods. And so therefore, if we wanted to access this particular value, then we would have to use the swatches as the namespace for this. And so what this is ultimately doing, it's keeping count of every time we create a swatch class, it's going to count 1, 2, 3, 4, and so forth. And so what we're going to do is we're going to keep track of that with every iteration. So I'm going to go ahead and click apply. And let's see what happens with the swatch. And then we have a shader ball pop up. Okay, nice. And it turns out it's white. Okay, so it's behaving kind of just as we would expect it to. Okay, so that's good. Now what we're going to do is add some functionality. Now where it says the create swatch, we're going to add a whole bunch more information in order for it to handle color information. So I'm going to go in and replace all this stuff. I'm going to put some more information in here. And let's see, we've got the create swatch, and then we have the self.top, which is what we did before. So everything is the same, but now we're going to create a brand new we're going to create a brand new variable name named ColorSop. Now this is going to be well, actually it's a color sop. So that's what it's going, and we're going to hook it up to our color node or to our shader ball, and then we're going to set its color to whatever our self color is. And then here it is, we're also going to create an output node, and then we're going to hook it up to our color node, and so we're going to set its display flag to be equal true. So I'm going to click apply here. So hope everything works well. And so we click the name here, swatches, and then we have a red one, because if you look at here, what we did was I said C1 equals swatches 100, meaning like, okay, make it red. All right, so I'm going to take advantage of this information, and so I'm going to move my container around a little bit in order to actually start creating multiple swatches. So I'm first going to say where we've got the container, and then I'm going to put in a little command here. So it says parm tuple translate, and then what I'm going to do is translate it along the z-axis, and we're going to offset it a certain amount according to what the swatch count is. Remember, swatches.swatch count is a variable that gets created when the class gets created, and then what we've told it to do is increment this variable every single time it gets called. So it goes 0, 1, 2, 3, and it's just going to keep on moving it along all the way. And I'm going to add one more thing on here. Self.top.layout children. And what this is going to do is it's going to lay out all of the children for the top node to make everything look like. And with that, I'm going to add one more swatch here. So C2 equals swatches, and then I'm going to make it green. Why not? Okay, click apply here. I'm going to get rid of my old one. Click here, swatches. And then you'll see that it automatically shifted everything over. How much? I don't know. I'm going to let the class take care of it. The class takes care of everything. You notice that we created a red swatch and then a green swatch. without any kind of shift or anything. Okay, now what we can do is we can tell the class, okay, start treating these things like objects, and so we can actually start performing some kind of operations on. So we have here is a red color, and then we have a green color. Now, what if we wanted to do some simple mathematics, like we wanted to add the two colors, you know, red plus green? Okay, what is that going to create? So let's go ahead and create something, and this is what's called as an operation override. And I'm going to insert that right here. Okay, you'll see that it also has that underscore underscore, and it's put under add. So add underscore underscore add underscore underscore. And then we're going to go call self, and then something else gets tossed along. It's called other. And that is the name of the other variable that gets sent along with it. And what do we do with that? What we're going to do is return the class, but we're going to do it with the colors added with each other. And here's self.color0 plus other.color0. Self.color1 plus other.color1. And self.color2 plus self.color2. And so we're going to add together, and they're going to be combined and create a brand new swatch. So let's just put that down here. So C1 or C3 equals C1 plus C2. All right, I'm going to click apply. And then everything should be fine. So I click this swatch, and now we have three colors. And everything's been laid out automatically because I'm going to let the class handle that. And now here, all it did was create this third one. All I did was add the two and just create a brand new swatch. So we could do that with multiplying as well. Now, if we wanted to multiply these two, let's take a look what that would look like. It's like almost the exact same function. Okay, but instead of saying add for the function name, we're going to say mul. That's short for multiply. And then it's the exact same thing, but it's self.color 0 times other color 0. And we're going to do that for color 1 and color 2. And so let's see what that looks like. So C3 equals C1 times, we're going to change that to times. So it's C1 times C2. Click apply. And then click this. And there it goes. And why did it turn black, you might say? Well, that's what happens when you multiply red times green. Who knew, right? So when you multiply red, the red channel of 1, which is 1 times 0 of the other, you get 0. The green channel of 1 times the green channel of other, which is 0 times 1, you get 0. And of course, the blue channel is that. Now, what if you wanted to create the inverse? So you didn't want to deal with another variable, you just wanted to create the inverse. Well, Python provides that as well. So we're going to go ahead and create this. And then their function name is called invert. All right, so we have underscore underscore invert, and they're the same. And now notice that we're only going to call self. We don't have to call others. So what we're doing now is we're subtracting the color from 1. Go here, there. This is for the red channel, the green channel, and the blue channel. And so now let's see if this would work. Let's say C4 equals tilde C1, meaning like, okay, make C4 equal to the inverse of C1. Okay, I'm going to delete that. Click along. Hello. Okay. It didn't work again. Oh, guy. It was going so great up until this point. Let's try this once again. Tilde C1. We got invert. Click apply. Swatches. There it is. Okay. Now this fourth ball, look at that. It's the inverse of red. Now, who out there knew that the inverse of red was cyan? Well, it kind of makes sense when you think about it. It's all green channels and blue channels and no red. Okay, but that's what we get. Now, suppose that we wanted to go ahead and really go bonkers and we wanted to go in and randomize something. We wanted to create a randomized swatch. Okay, what we could do is create an entire function to create a new swatch, kind of like that, but with a new random element. So let me click and create the new function here, and I'm going to put that right down here. Okay, rand. Okay, rand self creates an empty swatch out of an empty Houdini color. Okay, so here's where we're going to create a Houdini color, and then we're going to create a random hue. So it's random.random. So, oh, wait a second, random. We have to call in another library. We have to get the random library. So instead of class here, I'm going to put up here import random. Okay, the random library is needed in order to get any kind of random values coming out here. All right, so we've got that. And so hue is going to give us a random number somewhere between 0 and 1, and we're going to multiply it by 360, which means we're going to get a variable, random number between 0 and 359. And then we're going to put that value and set the hue, saturation, and value, and then we're going to create a brand new swatch based on that new color value. All right, so let's say C5 equals, let's call C2 random. All right, click apply. Oops, and there we go. We created our brand new swatch, and we have this new random value, which is some kind of random value based on this initial green value. Okay, very cool. So that's all kind of working. As you can see, we were able to get a whole bunch of shader balls cranked out there with some very little bit of coding. And look at that, it's creating random colors all left and right. So we know that it's working. All right, fantastic. All right, well, that was what I wanted to cover today, folks. And I'm going to shift my view over into my display here. All right, I'm going to change this over right now. Okay, all right. And okay, I'm going to move this over here. Okay, now I promise that if you join me for today's Houdini Secrets Live, we're not going to end up with such kakamaka, and we're going to end up with Houdini behaving nice and properly for us. So join us today at 3 o'clock for Houdini Secrets Live on this channel. And we're going to give a quick introduction to VDBs, and which is kind of good because I think I know what we're going to do in the weeks to coming in Houdini Secret Lives, and this VDBs is actually a good prequel. And so, therefore, next week, join us for Tech Art Talk Live. That's on the 19th of February. And when we're going to be dealing with, we're still going to be dealing with classes and object-oriented, but we're going to be dealing with inheritance. And actually expanding it one more further is to actually create not only classes, but we're going to create children of classes or classes inside of other classes. Okay. Now, if you liked what you saw today and were possibly entertained by all the antics I had with Houdini fighting with me, hit subscribe. Maybe it's tons of fun. Okay, check me out on YouTube and check my name, Chris Rhoda. I'm on Facebook and on LinkedIn. And if you're interested, check us out also on TechArtEDU on Facebook and on LinkedIn. And then, if you really want to do me a favor, folks, here's what you can do. Go ahead and go to my techartedu.com website. Now, this is the website for all of the shenanigans going on for all the shenanigans going on here at TechArt. There's a lot of stuff going on. We're getting very close to getting done with the procedural gems. We only have one more interview to transcribe. We're getting very close to finishing up the real-time visual effects for tech artists. That's all coming along, and a whole bunch of other goodies that are coming along. So come to the website, check out the status, click on the little click here now, dealio, sign up for updates, sign up to get informed of all that is going on, and we will keep you updated the best that we can whenever things are happening. So That would really be a big help. So thank you very much for joining us today. We'll see you later for Houdini Secrets at 3 o'clock. And otherwise, I'll see you next week, next Friday, for Tech Art Talk Live. Bye.